So and then we move to the open and closed loop system. So industrial control systems are also classified by how they control variables, either manually in an open loop system or automatically in a closed loop system. Okay, you already learn a control system courses. So in the control system also be introduced on the open loop and closed loop system. So the open loop system basically for the manual process, and then the closed loop system because of we want to make the automatic process. Okay, so open loop open loop system depend upon a common signal to inform the output device what to do, and the closed loop control systems closed loop system are self-correcting and allow for continuous operation without interruption. So meaning that this is we have a feedback input. Okay, we move to the feedback control after introduce to the open loop control and then closed loop control. So still under the closed loop control, okay, because under closed loop control you can find out the feedback signal. So that's why we introduced the feedback control. So industrial automated control is performed using closed loop system. Okay, a lot of automated industrial automated control you can find it from the big plant, okay, and also IC designs, or even though in the farming industries and also the food packaging industry. Okay, so a lot of industry apply the automated control. The term loop is derived from the fact that once the common signal is entered, it travels around the loop until equilibrium is restored. Okay, and then the operation of the closed loop system. Objective of the closed loop system is to keep the control variables equal to the desired set point. Okay, so you need to know the control variables, whether it's temperatures or pH value or humidities. Okay, so all the control variable equal to the desired set point. Okay, measurements device monitor the controlled variable and send a measurement signal to the error detector that represent its condition along the feedback loop. An error detector compares the feedback signal to the set point and produce an error signal. Okay, so when it compare the feedback signal and set point, then produce the error signal that is proportional to the difference between them. The error signal is fed to the control, which determines which kind of action should occur to make the control variable equal to the set point. Okay, so here that the controller, okay, try to adjust, okay, calculate the determine the kind of action should occur to make the control variables equal to the set point. The output of the controller causes the actuator to physically adjust the manipulated variables. Altering the manipulated variable causes the condition of the control variable to change to desired value. The basic concept of feedback control is that an error must exist before some corrective action can be made. An error can develop in one or three ways. Okay, so this is the example that might be the error occurred because of the set point is changed. Okay, suddenly you change, before this you set it to maybe 10, the temperature is 10 degrees, and then you change it to 20. So when it suddenly change, there could be an error there. A disturbance appears. Okay, whether is the environments, the disturbance is from the environments or from the circuit itself. Okay, so disturbance appears, and the load demand varies. Okay, and then the feedback signal may be either positive or negative. So because of changing of the set points. If the feedback signal polarity at a command input signal, it is said to be positive or regenerated feedback. Okay. If the feedback signal pulls the input signal, the system is said to use negative or degenerative feedback. By combining negative feedback values from the command signal, a closed loop system works properly. The central heating system in the house is one of the examples of the feedback signal. Okay, this is one of the example of the control systems. As you can see, this is the thermostat. Okay, use a negative feedback signal to control the temperature of a house. Okay, so as you can see that this is a negative feedback. As before this I explained it. Negative feedback value from the command signal. Okay, a closed loop system works properly. So because of this is a closed loop system, they need to compare the set point and feedback signal. Then by comparing that, the input from the comparison between that signal, okay, set point signal, and also the feedback signal will be sent to the controller. Okay. So this figure show the closed loop temperature control system. Okay. So as you can see from the figures, the feedback signal could be introduced because this is the applications of control closed loop system. Okay. So the feedback signal will again the input from the thermal sensor. Okay, the thermal sensor. Then they compare the set point signals. Okay, which is obtained, okay, from the actuators. Okay. So after we finish the feedback signal, I introduce you the feed-forward control. Okay, what the difference between the feed-forward control and the feedback signal. So two factors can make feedback control ineffective. Okay, two factors can make the feedback control ineffective. So one is large magnitude disturbance. Okay, and then the second one is the large process lag times. Okay, so this is the factor, okay, that make the feedback control ineffective. Okay, because of that, then we introduce the feed-forward control. So the feed-forward control prevents errors from occurring. However, feed-forward control is seldom used alone, typically in conjunction with feedback system. Okay, for the real applications, so feed-forward signal not only implement the feed-forward signals alone without the feedback signal. Okay, So for the real applications, both of signal, okay, from the feedback signal and feedforward signal be introduced to apply for the feedforward control. Okay, from the figure you can see the feedforward control of a temperature control systems. So where the signal or the input gain for the feedforward signal is from the cool waters, okay, the thermal sensor will be introduced for the feedforward signal. Okay, so this is the examples, okay, how it designed the feedforward control together with the feedback control loop. Okay, so feedback signal we still introduce the thermal sensor as the signal for the feedback signal and also for the feedforward signal, but the location is different. Okay, so the feedback signal, the thermal sensor being introduced at in the tank, okay, whereas the feedforward signal, okay, the thermal sensor located at the cool water.